Welcome back, class. Last week I showed you a spreadsheet of the miles ridden by each of the 30 riders in last summer's rally. This week I'm going to add 3 more variables to that array, one for each of the factors that Fiona, Sheila, and Sherman thought explained best the variation we saw in rider performance last summer. My short names for these variables are grit, genes, and privilege. To include these variables in our data set, we need to give each rider a score on each variable. So, after last week's class, I sent a questionnaire to the 30 riders and used their answers to score them. The first question I asked was this: how many times in the last year did you fail to turn in your homework? This is one way of measuring motivation, persistence, and focus, which I call the grit variable. I graded the riders' answers to the homework question on a curve from 1 to 10, depending on the number of times they failed to turn in their homework. The more times a rider failed to turn in homework, the lower his grit score. I then entered the riders' grit scores into column C of the spreadsheet. And by the way, from now on I'll be indicating the grit variable with the letters GR. For the gene scores, which I will indicate with the letters GE, I asked a different question, but used the same method. The question was, how many times in the last year were you too sick to come to school? This is one way of measuring a rider's natural-born physical constitution. I graded the answers to this question on a curve from 1 to 10 and entered the scores into column D of the spreadsheet. I indicate the privilege variable with the letters IN, which stands for investment. Here I used a different approach to score the riders. When I heard Sherman say that the Grapes have better bikes and get more coaching than the other clubs, I did a little investigation, and here's what I learned. It costs nothing to join the Apples, but you have to bring your own bike. The Apples have no coach or training program. It costs $100 per year to be in the Oranges, and the club provides the riders with used 3-speed bikes. The moms and dads take turns supervising training sessions every Saturday during the school year. For the Grapes, it costs $500 per year to join. The club provides the riders with new 10-speed bikes and hires a coach to train the riders on weekends during the school year. Now, there's no easy way to measure how much each rider's parents invest in her equipment and training. So, to create scores for the IN variable, I simply entered 1 for each apple, 2 for each orange, and 3 for each grape into column E of the spreadsheet. So we now have an array consisting of 4 variables in the columns and 30 riders in the rows. For each rider, we have observations of each of the 4 variables. In this array, M is the dependent variable because we expect that a rider's M score depends in some way on his GR, GE, and IN scores. GR, GE, and IN are the independent or explanatory variables. They don't depend on the M values, but we expect that they explain the M values in some way. This is the data set we'll be working with for the remainder of this term. As I said last time, the 2 objectives for this course are to understand the degree to which GR, GE, and IN explain the variation in M observed last summer, and to use that understanding to make predictions for rider performance next summer. In next week's class, we'll begin using statistical tools with the dataset to achieve these objectives. The first of these tools is analysis of correlation. Correlation measures the degree to which the values of 2 variables change together. We'll look at the correlation between M and each of our explanatory variables in 2 ways: visually, using XY plots on a graph, and statistically, by calculating a quantity known as the coefficient of correlation. Our conclusions from the visual analysis will be rather subjective, while the statistical approach will be more rigorous. I'll see you next week.